This is Shikant, and today I'm here to talk about a project that I've built using FastAPI and HTML for Cosmofoil's application process. First of all, I'd like to thank the team there for giving this really interesting um, task, uh, and I think it really shows um, this task really shows what they want out of an applicant, and which is really interesting, and I had lots of fun doing this. Like, this is not like a perfect system out there. A lot of changes and additional modification could be done to this code, but like for now, what I wanted to showcase with this project is that the way I work and if it resonates with the team at Cosmofoil or not. So, yeah, so starting off, we were given a long list of information regarding what is to be expected in the final version of this project. So basically, to give an intro about it, it's a natural language to SQL query assistant. So we'd have people that would just type in some query in their own natural language, and this has to convert it into SQL query and query it in the database and give a meaningful output back to the user. So, um, like, uh, so especially in a system like this, a lot of prompt engineering has to be done, and one has to know a bit of much to um, force LLMs to give what we users want. Like, if we generally go into OpenAI and just start saying that, like, I want some SQL query doing this, doing that, there would naturally occur a lot of errors. So that was the main problem to tackle in this case, and this is an interesting problem to solve as well. And yeah, so to start off with, like, the basic system architecture is there. I wouldn't go too much deep into it. So, like, maybe I'll just open the architecture file. So yeah, so it's a so this is all a big, like, multiple Docker containers that could be run in production somewhere using some load balancer like Nginx. But for now, it's just a Python server that has to run Uvicorn, and on the backend side we have to set up the database itself as well. And the data set for this was from Kaggle, um, this one. So we have to download it, put it in the database. This part has also been optimized, um, automated, and we can just run Docker Compose up, and the database would be set up for us. And similarly, our fast API backend plus the HTML frontend as well. So generally, to begin with, like, um, the architecture was pretty simple, as this was already um, predefined for us. So we had to use HTMX plus FastAPI for backend, and we could use any sort of LLMs, open sourced, from Hugging Face, from Google free API. But I had some few dollars remaining in my OpenAI account, so I went ahead with OpenAI API, as OpenAI is probably better for a lot of things. And plus, I wanted to make use of the money that I had in the account as well. So for database, I was more familiar with Postgres database, as I was using it previously as well. So I just went ahead with that. So we could go with any other SQL databases as well, but Postgres is the one for me. And so yeah, if you look at the system, generally the query hits the generate response function, which then hits the OpenAI API. like this happens multiple times. uh, so this is a two-step query generator, which I'll go more into later, but I just wanted to show you the system architecture. And this generate response function will be dealt in more, like explained more in detail later. So we have input, query, like process the first call with all the input defined here and again, and then the SQL query is generated. After the SQL query is generated, we just run the query against the database, and if it is successful, like we show the successful response. If it is not, an error message is displayed to the user. So yeah, um, so now, oh sorry, I would like to move on to the algorithm that I have for this. So I was loosely inspired by RSL-SQL paper. So this was written back, like I think it was submitted back in 2024, and this basically tried to uh, create a robust robust system that used the schema of the database to generate it. And I tried several other methods as well, like simple methods, but this turned out to be one that really struck me. Schema linking in particular is something really important, and for this project itself, I haven't implemented the whole set in itself, as in like there's like three steps, and the problem with it is like multiple calls to LLM might might equate to slower response rate. So for now, I've only done two because it works kind of fine. But like self correction, multi turn self correction, all that, if implemented correctly, this goes a long way, which I will implement later. And um, now I will show you how it show how this my approach differs from this paper. However, I have taken a lot of ideas from it. So like system prompt building ideas, I'm majorly inspired by this paper. So system prompt building, more or less it's all defined in that paper. And however, the first and the second step is quite different now. So this is the architecture I'm going with. So in the first API call, I use the database schema. I use the user query, few shots examples of how the output should be, and database data snapshots as well. Like even though we have schema, we need to show the LLM like this is how it is there. So one quick example would be like in this database, uh, the D is saved as 0, 1, 2, 3 rather than Monday, Sunday, Tuesday. So that is something that um, LLMs will not easily pick up if it is not shown. So all of these are very important part of building the um, SQL query. So I've passed in all of it, and in the end, after sending it to OpenAI, I use the response format API as well. So here, as I've shown, RF is response format, and I am generally more comfortable with JSON schema. So I've used JSON schema, which is pretty like good, and it has been developed since the past 2 years, I think, as far as I can remember. So it's pretty robust, and it's better performing than, for now at least, it's better performing than using the response format of using Pydantic base classes. So I've used that, and the reason I've used it is because like uh, I just want two things. I want the query to be rephrased into something more appropriate for this database, as I've sent in so many things, and I want it to uh, give me the exact tables that are required to create the final SQL query. So this is something that goes on into the second API call, along with few shots example, database schema, database data snapshots. So along with this, I've created this very robust SQL generating machine now. Mm, a few additional better things that can be done here is that for the final SQL generation, also we can use response format, but for that we would have to define all the SQL grammar, which would take a lot of time, but that would make it more accurate in the long run. But for now, this suffices. Okay. So now moving on to how it is set up and all, it's all there. To set up the database as well, I've created the README file. Mm, It's pretty straightforward now. And now I'd like to run the application itself. So since the database creation and uploading the data takes a little time, so I went ahead and did that already. And since the database is quite huge and cannot be uploaded at once, or at least it is not recommended that we do large data set bulk upload at once. So I did it in chunks just to make it safe and error free. Now that the database is ready, I would so this is my virtual environment that I've already created. So here's the main file. Okay, now I would like to run it. So this is how the final thing looks like. Heavily inspired by ChatGPT, of course, but there are some few tweaks like this, and yeah. So maybe we can just start by saying list the top 5 busiest airports by the number of flights. As you can see, it is processing. After it processes, it gives us the response in steps. Like this was the first step. So it has rephrased the query into this, and has told us that like these two tables are required. Hey, it is nudging the second prompt into this direction now. So it is easy to generate the SQL query. So yeah, and if I were to be like most delayed airline, I don't exactly know what I mean by this, but I'm sure that can come up with something. So yeah, Spirit Airlines average departure delay is this much. So it is pretty interesting how it interprets and does things. So, well, like for further enhancement of this, we can even do in a mechanism where we can step in and like we can intervene in step one. We can change the rephrased query into something that is more appropriate. All that can be done. Yeah. And after the SQL query is generated, I've added a validator, like a rule-based validator that only allows you to use select statements, and if there is no limit in any SQL query, it automatically adds the limit to maybe 10 or 20 for now, because I don't want it to be flooding the whole screen. So that is the check I've added. So just to see, drop all the tables. This is something that should not be run at all. So let's see how it deals with it. Only select queries are allowed. Yeah. So this is it. Like simple application. Room for a lot of improvement, but this is a pretty cool use case of LLM as well. And that is the system that I've developed. And thank you.